In this video, we'll create a turret that we'll use in our platform game. So the turret is going to fire laser. It can fire it intermittently, or it can constantly fire it, and if the laser touches the player dies and has to restart the level. I'm going to look on the browser for a turret, and there is a model here that I like very much, which is exactly this one, and I'm going to click add it to my project. Here it is, and I'll start by adding a box collider to the model child game object, and I'm going to set this box collider size. This collider is essentially to prevent the player from walking through the turret. Set this, center it up, increase the size. Great. Next, I'm going to add another child game object to the turret. It's going to be my laser spawn point, and I'm going to add a tag to this game object, and I'm going to position it over here in front of the turret, like so. Great. So now I have the basics for my turret. I'm going to create the prefab. Let's rename it to laser turret, move it to the prefab folder, and now we're ready to start working on our turret script. I'm going to my scripts folder, I'm going to create a C# script called laser controller. Then open it up in Visual Studio. I'm going to start by defining the variables that I'm going to use on my laser controller. I'm going to start with its range. So I'm going to find laser range, a default of 100. And as we did with the platform, I'm going to create some variables to show and hide the laser. Choose float. Then another float with variation, by default half a second, and the boolean flag that I will use to define if I'm going to hide the laser or not. By default, our laser is going to be always on. Next, I'll have the boolean that I'll use to turn the laser on and off. I'm going to start it as false. Then I'm going to keep a transform that I'm going to use as the laser origin. And I will also have a line renderer component on my game object, which I'm going to use to draw the laser itself. So I'm going to jump back into Unity and add this component to my turret right now. Where's my turret? Did I delete it? I may have deleted it. That's weird. Okay. I'm going to, not a problem. Let's add it again. Here's my laser turret, and on the laser spawn point, I'm going to add a line renderer and apply the change to the prefab. That is really weird. I never thought I had deleted my turret. But anyway, let's go back to Visual Studio. So now I have the line renderer on my prefab, I can get a reference to it. And renderer, get component, renderer, and I'm going to set its position as zero.transform position. So meaning that the first vertex of my line will always come from transform.position. Again, jumping back to Unity real quick, the line renderer is in my laser spawn point. So the first vertex of my line will always be at the tip of my laser. Now, going back to my script, I will check if I'm hiding my laser. If hide laser, I'm going to start a routine. Let's create it here. Show hide laser, where I'm going to do something very similar to what I did for my platform. While true, you'd return new wait for seconds, and it's going to be the show hide time plus a random dot range between minus show hide variation and show hide variation. And then if I'm hiding, my line renderer dot enable equals false, else my line renderer dot enabled equals true. So I'm different than what I did on the platform, where I had to disable the render. I had to disable the render and the collider. For the laser, I just need to disable the line renderer because I want the turret to keep showing. And here I switch back and forth between is hiding. Okay. So if I'm hiding the laser, start coroutine and show hide laser. Great. Now on my update, what I'm going to do on my update, I'm going to keep checking using raycast if my line renderer is actually hitting an object. So first of all, I need to check if my line renderer is enabled. And if my line renderer is not enabled, I don't need to do anything on my update. So meaning when my line renderer is disabled, I can simply return. Otherwise, I'm going to create a raycast hit variable, which I'll use to store the result of my physics raycast, and I'm going to do a physics raycast. I'm going to start from the position of my spawn point, and my raycast is going to be forward times my laser range. I'm going to save the result on the hit, and the maximum distance of my raycast is the same as the laser range. So if I hit something, I'm going to check if I'm actually hitting the player. So, so if the game object that was hit has the tag player, for now, we're just gonna print a debug log just to check if the logic is working. Laser has hit the player, and then further on, we're going to change this with the game over logic. One other thing I need to do is I need now to stop my line renderer on the point where the raycast has hit something. So now I'm going to call line render dot set position 1 hit dot point. And what does that mean? Remember that on the start function, we're setting the vertex number 0 of our line to the spawn point. Now that I'm hitting something, I'm setting the vertex number 1 to the point where something was hit. I'm going to save the script, go to my project. I'm going to apply this script to my laser spawn point. And I'm going to keep hide laser unchecked for now. I just want to test and see if this is working. I'm going to press play and let's see how it looks. Let's have a look. Something is not right. So let's check what is going on here. So we need to do some basic setup on our line renderer. First thing is I'll change the color of my laser to red in the beginning and in the end. Okay, then I need to add a material to my line renderer. There is a default line material here, which should work well enough. Now if I press play, I do have a red line being rendered, but it's way too thick and it's being rendered to the wrong place. The thickness of the laser I can configure here in the width. I'm going to set it to 0.1, and the line is being rendered to the wrong place. Maybe let's have a look at the script. Okay, and that is because we need to add the else condition here, meaning where should I write my line, where should I draw my line renderer in case I'm not hitting anything. And then in this case, I'm going to set the position of vertex number 1 to the current position of my spawn point plus transform.forward times laser range, and that should do it. Let's go back to our Unity project, press play, and now our laser is being drawn properly. It's being drawn forwards, and it is too tall for my character. So what I'm going to do is I'm going to put my chart a little bit lower. One adjustment I did off camera also is my laser spawn point, the game object that contains line render and my laser controller script. I've rotated it 180 degrees on the y-axis because originally it was facing inwards on the turret like that. So all you need to do is also rotate it at 180 degrees, so transform.forward, which is the z-axis, is actually pointing outwards. So I'm going to press play. And now let's check. Actually, let's put the console here, clear it up, and let's go to my laser and touch it and see what happens. Gonna walk towards the laser, and great. So now my laser is actually hitting my player, and you can see that it is stopping in the point where it's hitting the player, but there's no log on the console, and that's because my player prefab doesn't have the tag player set up. If I go back to my script, you can see that I check if the object being hit has the tag player. So that was not set. Now I set the tag, and now if I go towards my laser, now I have the console message being written as the laser hits the player. So great, our laser turrets are complete. Now let's just make one last test, see if the hide laser logic is working, of course. Let's go to the laser spawn point, hide laser every 3 seconds, and let's see if that is working. Press play. Where is our laser turret? There it is. Okay, it disabled. Cool. I'm going to wait for it to turn on again. And then I'm going to stand right in front of it. And let's see if and when it turns back on, it's going to hit me. There you go. It's hitting the player. Awesome. So we have the turret logic ready and working.